Alright, so chord properties on page 97. Okay, hope everyone's bringing their notes so they can look at the diagrams, they can draw on their diagrams. And of course refer to your diagrams when we go through the proof. Alright, so number 6. So we're looking at chords specifically. You've got 1, 2, 3, just 3 today, including a couple of Converse with a couple of them. Alright, so number 6. So the perpendicular line. Okay, everyone should know that perpendicular means meet at right angles. Okay, so you always form a right angle when we're talking about perpendicular. From the centre of a circle to a chord. So remember, a chord is any 2 points from the circle, a line through it that doesn't go through the diameter. Bisects the chord. So the word bisect means cut in half. Okay, so if you draw a chord and then a line from the centre perpendicular to that chord, mean either side where the two lines join will be equal in length for all cases. Okay, so wherever you put a chord, put a line to the centre, perpendicular chord on either side, it will be equal. The converse is also true. So when you draw a line from the centre of the chord to a chord midpoint, okay, that line will be perpendicular. It means to meet at right angles to the chord. Okay, so let's have a look at the proof. Right, so we're looking at proof 9.6. Okay, so reminder that the syllabus, the Board of Studies, requires you to know the proofs. Okay, I haven't seen an exam question where it's asking you to prove something specifically. The questions you are more typically going to get is showing two angles are equal or something like that. Okay, but of course a good knowledge of the proofs and how they work will go a long way in helping you understand the topic. So, we want to show that, we need to show that AB is the same length as BC. Those two intervals are equal. So AB and BC are equal length. Okay, so most of our proofs will involve congruent triangles, similar triangles, etc. And this is no exception. This will be a congruent triangles proof. Can anyone identify which of my 3 properties, the 4 proofs, sorry, that I will need to use to prove that those 2 triangles are congruent first? Good. Okay, there's a right angle there. Not always, but most of the time you'll be looking at the RHS test, the right angle, hypotenuse on the shorter side. In this case, you will. So, in triangle, just shorthand for triangle, you don't need to write the word triangle. Right, so OAB and triangle OBC. Alright, so I'm referring to the triangle on the left and the triangle formed on the right. Right, so let's go through the letters, RHS, in order. I'll just put them down like this. Alright, so I know what I need to go through to get the proof. So, I have 2 right angles already given to me in the diagram. Let's notate it correctly. So, the angle in the left triangle for the left angle, the angle in the left triangle goes first. So, angle ABO is going to equal the angle on the right triangle. Make sure we're notating in the correct order. The middle letter is your vertex. Okay, you need to state a reason for each step. Okay, in this one, the information was already given to me. That's the condition, because that line is perpendicular to the chord. Alright, the hypotenuse. Right, so opposite the right angle to the hypotenuse. So OA must equal OC. Why? What part of the circle is this? What part of the circle is this? Radii is the plural for radius. Okay, so now I need to show that one of the other two shorter sides in both triangles are equal. How am I going to state that or show that? So I either need to show that is equal to that or that is equal to that. OB. Okay, that's the common interval in both triangles. That means they must be the same length. Alright, so therefore, triangle OAB is congruent to triangle OBC because we used the right angle hypotenuse side test to show that they were equal, and that's enough to show the two triangles are congruent. Okay, and that will also mean matching the sides. That must be equal to that side. That's the common side, therefore this must be equal to that. So therefore AB is equal to BC. Matching sides in congruent triangle. Probably could have drawn triangles there. Therefore, perpendicular from the centre of the circle to a chord will bisect. Okay, so bisect means in half, cuts in half, or meets in half. Right, so nope. Okay, so what we're going to do now is to prove the converse is also true. Alright, so let's look at the converse proof. Alright. 1.6c, C for converse. Okay, there's a diagram. So what we need to do, so the statement is a line drawn from the centre to a chord to midpoint is perpendicular to the chord. So we need to show that angle OBA equals angle OBC which are both 90 degrees. Okay. So we need to show those two angles are equal. We need to do another congruence proof, and then from that we need to then state the triangles are equal. The angles, sorry, not the triangles. The angles are equal, which are 90 degrees. Alright, so this time you're told that AB is equal to BC. Okay, so we need to use one of the 4 congruence tests. We've got the triple side, we've got the side, angle side, where the angles include angle. We also have the angle side test, and we have the right angle hypotenuse side test. So which of the 4 am I going to use to show these two triangles are congruent? There's a right angle there? That's what we're proving. Good. Alright, so in triangle OBA and triangle. Okay, so you need to make sure we're starting our proof with this, stating the two triangles that you're using. Right, so we're going to use the triple side. So, what do we know? We know AB equals BC. Okay, that information is already given to us in the question and the statement. So the reason we write is given to us. Right, so like the last proof, OB is the common side in both those triangles. So we say it's common. And the last two sides, just like the last proof as well. It is an equal radii. Okay, so after we've shown those 3 properties, therefore triangle OBA is congruent to triangle OBC, and we use the triple side test. Right, so OB is common, so if I fold the triangle on the right over the common line that meets the triangle on the left, okay, so the vertex C will meet at A. That will be a way to help you identify which sides and angles are equal. If I do that, so therefore, angle OBA is equal to angle OBC. Okay, so now it's shown that these two angles there and there are equal. I've not shown their right angles yet. Okay, so I've shown those two angles are equal. Any ideas how I'm going to show that they are both 90 degrees? Good. Okay, the next part of it, so since ABC, so the interval ABC is a straight line, okay, because it's a chord is a straight line, okay. So right arrow means implies that angle OBA plus angle OBC is equal to 180 degrees, which also implies that angle OBA equals angle OBC, which equals 90 degrees. Okay, so it's not enough to show those two angles are equal, you need to also show that they are both right angles so that we get the perpendicular statement. Right, so therefore a line drawn from the centre to a chord's midpoint is perpendicular. To the chord. Okay, that's the property we've just shown. But any questions? Okay, so it works for any chord in any circle. Okay, so you draw any chord, join that chord up with the centre. Okay, that's perpendicular, it will bisect the chord. Okay, if you draw a chord, draw a line to the centre, to the chord, so that each side of the chord is equal. The line you've drawn from the centre to the chord is perpendicular. Right. Right, number 7. Okay, so number 7 on page 98. So, equal chords are equidistant from the centre. Okay, equidistant means equal in distance. Okay, that's the actual word. Okay, so if you have two chords that are equal in length, right, and then you join them up to the centre using the property that we've just done, right, means those two lines are equal in length as well. Alright, this converse is also true. If you draw two lines from the centre out, which are equal in length, and then you join them up perpendicular to the chord, means those two chords will be equal. So look at the proof. 9.7. Alright, so equal chords are equidistant from the centre. So we know that DF is equal to AC. We want to show that OE is equal to OB. Okay, so we know DF is equal to AC. Okay, from the last property, we know that also DE is equal to EF. That might come in handy. So this part here is equal to that part there. And AB is equal to BC. That's what we know. We can't just state though. We are told only the first one. If you are going to use the last two properties there, you will need to give that reason as to what we've done in the last property. We need to show that EO is equal to OB. That's what we're showing, that these two lines here, intervals so, are equal. Right, so I've got another two triangles there, so I must be looking at another congruence proof. So in triangle DEO, and triangle AOB. Right, so what test am I going to use? Keeping in mind that I am showing this is that equal to that. RHS is correct? Right. Right, so angle DEO is equal to angle OBA. Right, so even though that information is given to you in the triangle, it shouldn't have been. Okay, but in this case you can say given, because it's shown to you in the diagram. Okay, otherwise you will need to state a reason why, along the lines of what we did in the last proof. Okay, so that's the right angle, hypotenuse. So DO is equal to AO. What's the reason? DO, AO. Equal radii and the shorter side. So I can't state these two because that's what I'm proving. Okay, so I need to say that DE is equal to AB. Right, so you are told that the whole chords are equal. Okay, you are not specifically told that DE is equal to AB in the diagram. Okay, so what you must do here is state the reason. Okay, so you need to say the perpendicular from centre to the chord bisects chord. Okay, that will do. Hang on. Bisect chord. And also we know that DF equals AC. That part of this was given. Okay, so we also need to make a note that because these two chords are equal, when we do the perpendicular, we mean those two smaller components will also be equal. Okay, not enough to say two generic chords, means those intervals are equal, because you need to know that those two chords are equal in length. Right, so therefore, triangle DEO is congruent to triangle AOB. Alright, we use the right angle hypotenuse side test. Okay, therefore EO must equal OB because they are the matching sides. Okay, so therefore equal chords are equal distant from the centre. Okay, so that was what we were showing all along. Alright, any questions on that one? Now what I want to do, there is a converse, I am going to come back to that. I want to go to the next one, then do the example so that you can got some work you can do, and then if we have time at the end I'll go back and prove the converse. Okay, because I'm not looking like I'm going to be here Friday, so there will be no lesson on Friday. So if I can get it all done so you can have a working lesson Friday, either if you come in the morning or do it in your own time. Okay. Alright, so number 8 we're up to. Right, so we're going to come back and do that one. Number 8. So we draw 2 chords into a circle. Okay, the interval between that cross and the circumference. Alright, so if we go along the chord, A times B, the product of those two there will equal the same as the product of C, D over there. Okay, and that'll work for any 2 intersecting chords. Alright, so that's number 8. Let's have a look at the proof. Proof, what are we up to here? 9.8. Nope. Nope. Okay, so here's our proof. So ignore the dotted lines, we don't actually need that in our proof. Okay, so we're going to ignore this part, we don't need that. Okay, there's another way to prove it, but because we already know some things, we don't actually need it. Right, so we need to show that, so we've got 2 chords, we've got the chord CD and AB, where they join the centre at E. So we need to show that AE times EB, so going along the same chord, stopping at the interval, where the intersection, AE times EB is equal to CE times ED. Okay, that's what we're getting at showing now. Right. So, the chords AB and CD are just 2 general chords. You have no specific information about any of those. On the diagram, there is no information there to suggest that any 2 sides are equal. Okay, because all your 4 congruent proofs require at least one of the sides to be equal. Okay, I do not have enough information there to show, generally speaking, that 2 sides are equal. Alright, so what we need to do is do a similar triangles proof. So what are the conditions, does anyone know, for 2 triangles to be similar?
Angle, angle, angle.
All 3 angles are equal. What else? You're on the right track. All 3 sides must be in the same ratio. Okay, there are 2 main conditions. So what we're going to do here is we're going to do the angle, 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 show that the 3 angles are equal, because we do, or you have been shown that all 3 angles are equal. Okay, so when we do that, we'll be able to look at the sides. Alright, so in triangle AED and triangle CEB. Right, so that top triangle there and the bottom triangle there. Right, can anyone identify two equal angles in the diagram using properties that you know already or you have been shown in this topic? Pardon? Yep. Yep, angles in the same segment. Butterfly wings, yes. So, that means that angle and that angle are equal. It'll mean this angle and this angle is equal. Okay, so we're looking at the butterfly wings, tip of the butterfly wings. Those two angles are equal. Okay, so when you have two chords and then join them up. Okay, and then we also need to then show that these two angles are equal. You should be able to use your previous knowledge from before year 11 to be able to tell me why. Right, let's start with the first two. So angle EAD is equal to angle ECB. Okay, so these are the butterfly wings. The formal statement is angles in same segment. Okay, so remember the segment is referring to the arc. So that's the segment that we are referring to. Are equal. Right. You also have the second arc here, and that's the segment, and those two angles are the tips of those segments. So angle ADE is equal to angle EBC, making sure your angle notation is correct. The middle letter is the vertex. Okay, you will not get your mark if you are not getting your angle notation correct. Right, same reason, I'm not going to write it all again. I'm going to say as above. Okay, I've already stated it, I'm not going to state it again. Right, next one, angle AED is equal to angle CEB. There's two simple reasons as to why. Can I have both reasons, please? Let's go back to year 9, year 10 work. Maybe even year 8 work.
This is something I threw out. I didn't want it. Oh, yeah.
Vertically opposite angles are equal.
That's it. I knew that.
Okay, that was one of them. What's the other? It's slightly more detailed, but what's the other way I can show those two angles are equal? Something to do with angle sums triangle. Okay, so you know these two angles are equal. You know the angle sum is 180. Okay, because those two angles are equal, by the process of angle sum in the triangle, you'll be able to show that those two angles are equal. However, we've got a nice quicker reading there. Alright, so when we've shown that three angles are equal, the two triangles are similar. They're only congruent if the sides are equal as well. Okay? So therefore, triangle AED. Similar is 3 vertical lines. Okay, congruent to horizontal, similar to vertical. Triangle CEB. Okay, you can either go triple A or you can say equal angular. Okay, one or the other will be fine. Now, I said that the sides are not necessarily equal. However, because the angles are equal in both triangles, the sides will be in the corresponding ratio. Okay, they will have a ratio to all the sides. So if I take my matching sides of my triangle, okay, because the angle here and here are equal, and the angle here and here are equal, these two sides here and here will be in the same ratio, the sides that make the same angle. Okay, likewise with these two sides, and likewise with these two sides. Same sides that make the same angle will be in the same ratio. And that ratio will be the same for each of those sides because the triangles are similar. So, therefore, have you ever done similar triangle proofs before? Okay, so we will cover it more in mathematics, okay, so I'm showing you now so that you can do the question, but when we do geometry and mathematics starting next term or the end of this term, I'll show you more detailed about similar triangles and just stick them to triangles, not just circles as well. Alright, so that means AE, the ratio of these two sides, so the ratio is the fraction, okay, so the length of AE compared to the length of CE, so they're the matching sides, must be the same as the ratio in the other two, so ED, over the matching side, EB. Okay, now next to it, can you put a bracket, which also equals the side AD from the top triangle and the matching side of the bottom triangle, which is CB. Okay, but for this proof, I'm not going to use the last fraction. That's why it's in a bracket. Okay, this ratio gives you the scale factor. So if you've ever done work with scale factors, okay, that's what we're doing. Okay, so let's say the reason, matching sides in similar triangle in same ratio. It means both these fractions will simplify down to the same thing as well as this one if we knew the length of all the sides. Okay. So, I want to cross multiply because of the equal sign and take the denominators away. So, which implies the AE, so I'm going to cross multiply. There, AE times EB is going to equal CE times, let's take that up the top, times what's already up there. Okay, so AE times EB is equal to CE times ED. Okay, so that's the proof. If you didn't quite follow that, that's okay. We will cover it in more detail in mathematics when we do geometry. Right. Good plenty of time. Is there any questions on any of that? Just people make somewhat of an understanding of what's happening. Alright, let's do these 3 examples and see what time we have left to do the other proof. Alright, examples on page 99. Alright, A. Alright. 3 quick examples here, just incorporating what we've done today. So, OD is 50 millimetres, OE is 30 millimetres. Find the length of DE, this side here, and DF, whole side there. Alright, so how long is DE? So O, that's 50, that's 30. How long is DE? Hey? Well, what's the maths involved for me to work out it? Good. Yeah, why? Good, excellent. So, right angles here as well. You know the length of the hypotenuse, you know the length of this side. By using Pythagoras theorem, you'll be able to determine the length of DE. Anyone here does not remember Pythagoras theorem? So, DE equals 40 millimetres. Okay, state the reason. I think most of you here learnt Pythagoras theorem through me. Year 8 maybe. Still important in Year 11 maths. In Year 11 extension maths. Okay, so if you weren't quite sure, you need to state this is the rule, c squared equals a squared plus b squared, and go through the proof. Alright, so DF. How long is DF? Which is the whole chord there. Okay, will be 80 because we know that's 40. Okay, the property is the chord perpendicular to the centre to the chord bisect, means this length is the same as that length there. So our DF, which is the whole chord, the DF is going to be 80 millimetres. And you need to state your reason, please. The perpendicular from centre to chord bisects. Okay, so all you need to say, state in property why you know they're equal, and then that will do. Okay, you don't need to be tedious in every single little step. Right. Find the length of PR, which is the chord here, if OQ is ON, which is 15 centimetres, and MN, that part of it there, is 14 centimetres. So first thing when you're doing is reading the question, making sure all that information is in your diagram. Right, so what is the length of PR? The whole chord here. 28, okay? Because we've got equal lines from the centre, they will form equal chord, okay? We're told this length here and here is 14 from that property of the perpendicular to the chord bisects the chord. So the whole chord here must be 28, double that, and because these two are equal, this whole chord must be the same length as well. Alright, how do we answer it though? I would suggest you do something along the lines of this. So N S is equal to 14 centimetres. Okay, so I'm going to state this one, I'm going to state the length of the whole chord, and then I'm going to state the length of the other chord. Alright, same reason above. You can't just state as above because you're doing a new question. Essentially the chord bisects. Okay, bisect means cuts in half. Okay, we also know that PR must equal MS. Get the wording right. Okay, chords which are equidistant from centre are equal. So that must mean PR is 14 times 2, which is 28 centimetres. Okay, so if you're going to say that PR is 28 centimetres and that's all you're going to do, okay, you need to have a reason to back that up, and the reason must cover the whole process you did to get to that stage. Okay, so I would suggest you work through it bit by bit in your thinking so that you can, whoever's marking your papers, so me up until your very final exam, okay, will need to follow the reasoning as to why. Okay, last one I'm going to do this morning. Won't get back to that proof today, we'll do it another lesson. Alright, find the length of the chord CD. Yep, good. Okay, so what that'll achieve is you find the length here, you then ask to find the length of chord CD, so you have to do an extra step to do addition at the end. Right, so AE times EB going to equal CE times ED. Right, so AE is 5, EB is 14, is equal to CE, which is 10, and ED is what we do not know yet. Kyle, Robin? Right, 5 times 10, which is 50, 5 times 4, which is 20, so 5 times 14 is 70, is equal to 10 times ED, so ED equals 7. Which probably state a reason, product of intersecting chords are equal. which is true because 5 times 14, which is 70, 10 times 7 is also 70. Okay, you found the length of the chord. You were asked the interval. You asked for the whole chord, CD. So CD is equal to 10 plus 7. Okay, need to make sure you go back to the question, read it, and make sure you have answered it. Okay, so if you stop here, you will not get your full mark because the question had asked you to find the chord CD. Right. Exercise 9.2. Okay, additional to what is asked in the TAR, okay, you must state each reason. Okay, it is extra work, however, if you are doing that, if you are stating your reasons, you're getting very familiar with them. When we do proofs, you're going to find you'll be able to understand it a lot better than just writing values without reasons. Okay? So please, when you're doing exercises in this topic, please state the reason so you are getting familiar with them.
Are we doing a theory lesson or a practice lesson?
I'll be going on to the next thing. But there will be time, hopefully, for you guys to get some questions done. Okay? Okay, thank you.